welcome Alicia. Alicia is a scientist, a leader at SEM, an organization that provides technology for sample preparation, testing, and other type of services and technologies for the cannabis industry. Alicia is a PhD, molecular sample lead, research and development scientist at SEM. SEM Corporation. At SEM Corporation, Alicia worked with engineering to developing the H product, provide global support for the molecular sample prep division, and manage the molecular sample prep team. Also, while working in life science division at SEM, Alicia had the opportunity to work with engineering in order to develop new life science instrumentation, provide global technical and application support for life science products, among other great things that they are doing with cannabis. Alicia, welcome. Feel free to share your screen. Thank you for joining us today.
I apologize there. So hopefully you guys can see my screen now. And thank you for that introduction. And I appreciate the opportunity to speak to you.
Aprecio la oportunidad de dirigirme a ustedes hoy. Esta charla va a ser un poquito distinta con respecto a la industria de cannabis y con respecto a lo que hemos visto ya, pero pienso que esto es bueno porque hay muchos aspectos distintos a tratar.
So I'm going to be talking about simplifying sample prep for cannabis and cannabis-infused products.
No hay traducción para el resto de esta presentación. No hay traducción.
And currently in the United States, it's not federally legal. However, we have increasingly more states that are legalizing it for both medicinal and recreational purposes. But currently right now, the testing, and when I say testing, I'm referring to quality control. Okay, so that's where we're going to kind of get to the basics here. Regardless of your product, whether it is just the flower or an oil or these infused products, edibles and lotions and so forth, at some level, we have to deem them safe. And typically the list that I have here, pesticides, potency, metals, mycotoxins, terpenes, residual solvents, and microbiological screening are the main ones that the testing labs in the United States are required to look at by the law of their state. Now the lists are a little bit different. Some have, an extensive pesticide list they have to look for. Some don't have a very high list, but at some level, the ones listed here are tested in the states in which cannabis is legal. So CEM offers solutions for sample preparation for a number of these types of testing. So whether you're working on pesticides or potency, metals, mycotoxins, or terpenes, we have a solution for you to help bring automation and speed, efficiency into the lab. And obviously in the cannabis industry, this is really important because we're talking about labs that are popping up all over the place that, may not have the variety of scientists at their disposal that other labs may have. And so they need to be able to do this testing efficiently and ease of use and, and effectively. Now, the options I noted are what we offer in this screen. You'll see there's two different instrumentations. Now, for the majority of this talk, I am going to focus on the EDGE system, which is the one on your right, but I'll briefly touch upon our Mars 6 system, which does our metals analysis, because metals is obviously a very important sector, but it does require a different type of instrumentation. The rest of the analytes, the more organic contaminants or compounds of interest, such as the potency, you can extract via the EDGE system. And again, when I use the word extract, I'm talking on a QC level. So we're not doing large scale extraction of the oil from the plant. This is extracting the plant or the edibles or the infused products to determine from a quality control the percentage of these components in the sample. So just kind of back to that list, what I'm going to focus on is pesticides for the bulk of this talk. And pesticides, I think, arguably is probably one of the more challenging ones, right? So that's one of the ones that a lot of companies are needing a solution for. So, you know, I'm going to take even a step further back and, you know, why do we care so much about sample prep? Because honestly, it's very rare that you see a lot of people talking about sample prep. We talk a lot about the analysis. Sample prep is often glossed over. However, if you look at this pie graph taken from LCGC magazine a few years ago, you'll see that a staggering amount of our time today is spent on sample prep, right? We've come so far in the world of analysis. And that is, you know, it's amazing how quickly we can get data these days. But if we look and go into our lab and see that we're still doing a lot of glassware chemistry, a lot of manual work, there's a need to modernize the sample preparation for our products. And furthermore, if you don't do good sample prep, you don't get good data. And so it's important that we take the time to focus on how we're preparing these samples, particularly in the world of cannabis, where, you know, the percent of CBD and THC and, you know, the fact that there are, you know, not contaminated and safe is a very important thing. So in this talk, I'll be covering data of a wide variety of edibles, okay, from chocolate to granola bars, to hard candies, to chips. So obviously there's a wide variety of different samples here. And these samples have different components from high sugar to high fat and so forth. And those other components in those samples affect the way you, you know, how it is to work with these samples and get data. And typically, when you look at the variety of samples I have listed here, that's a challenge. It's a challenge to be able to work with these samples. What we're going to see here is we're going to offer one method, regardless of sample, from all these different sample types in the plant itself that we did to do the sample preparation. I'm going to talk about pesticides, but you would use a very, very similar method for potency and mycotoxins and terpenes as well. So what I'm going to talk about is our EDGE system, and here is just a schematic of that. However, I got a video a little bit later on where you'll see it actually running, and I think that will bring more to the table. The point of this graph here is simply to show how easy it is. Not a lot of steps. You basically prepare your sample, you bring it to analysis. The EDGE system is going to do all that sample prep for you. So some of the benefits that you get by using the EDGE system to extract pesticides from cannabis-infused products are, number one, it's a multi-matrix, multi-residue method. Now, the standard method to use to extract pesticides is the Ketchers method. So if you're familiar with pesticide extraction, I am sure you have heard of Ketchers before. And Ketchers is a multi-matrix, so a lot of different sample types, multi-residue, so a lot of different pesticides method. And obviously we want that. We want one method that applies all. And what we'll see with the EDGE is that's true to even a greater extent than Ketchers. We can choose one method for a larger variety of different samples. Now, one thing that's great about the EDGE is we have complete control over the temperature. To compare back to Ketchers again, Ketchers is an exothermic reaction. So you don't have control over how much heat is being applied. However, in the world of pesticides, heat can be a negative thing. You can convert, especially in potency as well, you convert THCA to THC with temperature. So when we're doing these types of extractions, we want to be very cognitive of how high of temperature we're employing. And we do put a little bit of heat, but we keep it at like 40 degrees C. So not a lot of heat at all. And we have complete control over that. So we make sure that we're not damaging the material as far as degrading the pesticides or doing any conversion of the cannabinoids as well. In the world of pesticides, you see a lot of cleanup needed so that you get good analysis in the end. And you can do cleanup on the EDGE system. However, we didn't employ cleanup for the data I'm showing here. And more we're seeing that cleanup isn't necessary when you extract on the EDGE. But I want to note that it is possible. I hope you see as I continue to walk through the video and so forth, how simple the system is. When you bring automation to the table, you are allowing for better efficiency. You're removing the human aspect, right? So there's no human error. And typically, anytime you bring automation to the table, you're going to see better RSD values, better reproducibility. And another benefit that we've seen when extracting on the EDGE is we're seeing less matrix effects. And that goes back to not needing the cleanup. So if we're not extracting as much that's causing the ability to see our analytes, then we're able to get a cleaner extraction. So here's that video that I was talking about, and this just shows you the edge running. I'm a very visual person, and for me, seeing the instrument runs gives me a better perspective on what it can do. So that's our sample cell there, our Q cup, and you saw Brittany drop in our filter, which is our Q disc, and then you would weigh in your sample. Now it's very, very light and go directly on an analytical balance. You just weigh in the sample, and then you drop it into the rack with your Q cup, which has your sample, and then your collection vial. In the case for pesticides, you can use a centrifuge tube. So that would be the most common, is that you're just collecting in a centrifuge tube. A few quick clicks, and the edge is going to take over from there. So it's going to take that sample that was just prepared and load into that back chamber. The edge does run in series, so one sample right after the other, and it holds up to 12 samples. Once your sample is back there, this is a cross section of what's going on now. Your actuator is going to come down and create a pressurized seal. Then we're going to add the solvent, and we can add from both the bottom and the top. We're going to make sure our sample is fully wet with our solvent. And then there is an option of bubbling. One of the unique things about the edge is that we have an open system that we can apply agitation. So you can do this bubbling, and then you heat to a set temperature and hold time. Once you've reached that, the sample is going to drain through the sample, through that Q disc, which is doing the filtration, through a cooling coil, and then collected in that centrifuge that I mentioned. So once it's collected, that sample is ready to go for analysis. What you'll see depicted here is an option we have in our software for rinse, where basically just take clean solvent and you skip the pressurization and heating steps, you just drain it right through and collect that. And that just leads to higher recovery values overall. It's a quick way to get better results. Once that is completed, we do want to be aware of carryover. So we're going to remove our cup from the system, and then we're going to fully wash that fluidic pathway with solvent to ensure that no carryover occurred at all. And you'll see in the picture here in a second that that needle that's sitting over your extraction vial is going to go to the waste port in that back right. And so the same needle that just dispensed your extract is going to dispense the waste. So again, the entire fluidic pathway is washed, and it would then move on to the next sample. And you can mix samples, right? So you could be running chocolates one, gummy bears the next, hard candies the next, chips, the plant. You can mix samples and run them. And this is just kind of a feel-good moment of that sample that was just in solvent is now fully dry. So you know that you've collected everything and you've got your extract that is filtered and ready to go straight to your analysis. So hopefully that gave you a good visual of how the edge system runs and what it's doing. So again, I don't want to get into too much detail here, but I do like to, any presentation I give, someone could take it and be able to do that if you had an edge system actually run it. But here's just the details of what is prepared in that cup. So at the very bottom level, you have your Q disc. What we're using is a glass fiber Q disc that filters down to 0.3 microns. Then you would add sorbent, so any sort of primary, secondary amines, carbon black, C18, if you wanted. Again, we did not use sorbent for the data I'm presenting here today. For the data I'm presenting here today, we use 300 milligrams of homogenized samples. So that's all the different edibles. They were homogenized, and then we use 300 milligrams of each of those different edibles, as well as the plant itself. We then spiked, in this case, we spiked with the ResTech Oregon. So OR is Oregon, the state of Oregon in the United States list. As noted, it is a state-by-state regulation. So there's a lot of standards we're able to get for the specific states. So in this case, we were using the list that Oregon requires for regulation. And the spiking level was 500 ppb in each of those products that we spiked. And then we put on a Q screen. You see that pictured there on the left. All that is a stainless steel mesh that you just put on top, add it to the top of the sample to keep everything compact and in the sample. When we've got everything compressed down in the cell, it just leads to better extraction. And this is a screenshot taken directly from the Edge software that shows the parameters of the method. Again, I want you to know exactly what we run. In this case, our solvent was acetonitrile with 1% formic acid. we added 25 milliliters of that to the sample, and that was our first cycle. And then, as you noted, we had that option of a rinse. And so then we added an additional 5 mils and then collected that. So the total volume collected was 35 mils. It was held at 40 degrees C for 2 minutes. I showed the bubbling on that video. However, we did not do bubbling for these particular samples we noted here. You can see that as an option down at the bottom if you did so desire to do bubbling. And before I get into the data, I wanted to show this step. And I need to give out a huge thank you to Carl Ogeton with SciEx for this, because this data was done in collaboration with SciEx. And Carl is actually the one that did this winterization process and shared these pictures with me. And I was just really interested to see the dramatic results here, right? I mean, clearly a change occurred pre and post winterization. So the winterization process was the samples were placed in a negative 20 degrees C freezer for 2 hours. And then they were just decanted off and put into analysis. So no additional filtration or dilution was done. So the samples were pretty much taken direct to analysis, but this winterization process clearly, something's going on here. We got to look into more on how important this particular step is, but certainly the visual was interesting. So again, this was done in collaboration with SciEx. So here is the equipment that they used for the analysis, and I'm not going to go into great detail, but I believe these methods are available in their application notes that they would apply for for pesticide analysis. And then here is the data. So this here is just a snapshot of the data in an interesting way to kind of see from a very overall view how things were performing. And what was interesting is you would expect, given that wide variety of different products, flour, cookies, chips, chocolate, hard candy, granola bar, that we may see some samples that pulled out as more challenging than another. However, that's really not what we saw. It was pretty even across the board. Maybe the chips were on the lower end there, but overall, everything was in the acceptable range with good RSD values for the list of pesticides that we looked at. So this was, and keep a note, this is just raw data. So no internal standard correction here at all. This is just clear raw data. So it's very encouraging that we get such good raw data for such a wide variety of samples. And then this is kind of just an overall view of all the different pesticides and all those different matrices that we looked at. And again, the take home here is that good recovery and good RSD values were obtained regardless of sample and regardless of pesticide. So overall, very acceptable results for everything that we looked at. So I'm going to switch gears a little bit and talk just quickly about metals analysis too, because what I hope you saw from me talking about the EDGE is we offer a rapid, simple, and efficient method for the extraction of pesticides and potency mycotoxins. Again, you apply the same type of method regardless of the different analytes you're looking at. On the Mars 6, that's what you're going to use to do your digestion, which is going to lead for your metals analysis. And if you watched the little promo video just a little while ago, you saw Sam talking about metals analysis and digestion and how most states are required to look at the top 4 metals. So it's something that is required. And with the Mars 6, you can digest up to 40 samples per batch, so at a time, and the method is programmed in. You don't have to think of anything, you just have to pick the cannabis method. And again, it's the same method regardless of the matrix you're looking at. So all the edibles we just talked about, we'd use the same method for the digestion. And here's just some of the details on that method. Again, we have a method note, and this is applied to the plant, but it would be the same method for the different edibles and so forth as well. So again, CM is in the business of making things simple for you guys. So it's just drop in your sample in a vessel or a sample holder, and then the instrumentation is going to do the job from that point on. So, again, I only got 20 minutes here, so I went through this stuff pretty quickly, but again, I hope you see that we have a rapid, simple, and efficient sample prep options for both, from extraction of pesticides and mycotoxins and potency to digestion of the metals. So again, fast. I hope that was clear. I didn't go over the overall method, but if you looked at, we have like a 2-minute hold time. In about 7 minutes on the edge is start to finish. So in 7 minutes, you have an extract that you'd be taking to analysis. And a batch on the microwave system, so 40 samples, is going to be done in about 20 minutes. So really rapid turnaround time, regardless of the system that you're using here. And then ease of use, which again, I think is really important in the cannabis labs, particularly. I hope you saw how easy that Q cup or sample holder on the edge was, but our vessels on the Mars are just as easy. You heard Sam kind of talk about that. It's just a liner and a plug and a cap. That's it. Everything comes together quickly. And, I have automation listed under the edge there and reproducibility under the Mars, but they're true for both, right? You bring automation to the table, you get reproducibility. So just in conclusion, kind of sound like a broken record here, but our minds work. The more we hear it, we might remember it. So if you take the fact that, the edge can extract pesticides, cannabinoids, mycotoxins, and terpenes from both the flower and infused products. We talked about edibles here, but regardless of the product, we can run it if it's a solid or a semi-solid or small volume liquid. We can run it on the edge. The Mars 6 can be used to digest samples for the metals analysis in all of these products as well. And that both bring speed, simplicity, and efficiency to sample preparation. So if we go back to that pie graph that we saw at the beginning, let's take that 65% of our time that we're spending on sample prep and minimize that, because we don't need to be spending that much time, and we need to be getting better results faster. So just a little bit on CEM. We are where you are, and you guys are probably like, oh, you're showing me a map of the United States, and that's not as applicable to us, but this is true on a global scale. And I support these products on, around the world. We have a number of systems in Latin America. And we work with dealers in the Latin American countries. And so you're going to be able to reach out and get good support from CEM no matter where you're located. And so with that, I am going to thank my team. These are the faces behind everything that I'm presenting here. We are always available at molecular.support@cem.com. So 24/7, please email us and we will be there to answer your questions and hopefully help you bring automation and speed and simplicity and efficiency into your cannabis testing lab. So with that, I would like to thank you guys for allowing me to talk to you today.
Thank you, Alicia. Let's remember that all these type of technologies are available
Recordemos que toda esta tecnología está disponible en todas las Américas. Ustedes pueden contactar directamente a CEM. Si están en Estados Unidos, pueden comunicarse con Kinos, que es representante.
Si estás en Colombia y deseas acceder a alguno de estos equipos, puedes contactar al distribuidor denominado Kimos. Yo dejé dentro del chat o el contacto directo de Alicia, molecular.support@cem.com, y también dejé los correos de Kimos en caso de que alguien quiera acceder y comprar alguna de estas herramientas en Colombia. En Kimos con mucho gusto los pueden atender. Siéntanse en libertad de visitar la página web www.kimos.com, Kimos, KHYUKMOS. Ahí podrán encontrar toda la tecnología de SEM, definitivamente, no solo para cumplir con las regulaciones que en algunas jurisdicciones son expuestas en términos de control de calidad y testeo, sino para nuestro control como empresarios del cannabis y para ser éticos con nuestros pacientes. Es necesario hacer este tipo de testeos para tener, uno, claro, cuáles son los niveles de cannabinoides que estamos obteniendo en nuestra flor, en nuestros derivados, extractos, cualquier tipo de comestible, lo que estemos produciendo. Y en términos de dosificación, bueno, sin este tipo de herramientas, pues es imposible generar una formulación magistral, por ejemplo. Entonces, muchas gracias, Alicia. Thank you so much, Alicia, once again. I have a question here, Alicia. How much are usually these machines? What are the price range? Tell us a little bit about it, please.
Yeah, I mean, definitely contact your local dealer for your prices in country. I can say that the list price for both systems is around $35,000 in the US. We do have a cost calculator on our website where you can see that you are going to get savings. Cost per test is less on both of these systems than the traditional methods. So in a short time frame, you actually pay for the cost of that system by incorporating in something where you're using less solvent. You don't have to use as many sorbents. So overall, there is savings with time.
Amazing. So 35,000 probably. Starting from that, you can access to this kind of technology. It's mandatory. I think if you are cultivating, if you are providing just dry flower, or if you are extracting any type of oil, if you are producing any type of edible or derivative, you need extraction. You need testing, extraction and testing, and sample testing, and all this incredible information that Alicia have provided. Recordemos que si estamos en Colombia o en la región, podemos acceder a este tipo de equipos en Quimos. Olga de Quimos nos ha dejado también en el chat sus correos equipo@quimos.com, info@quimos.com.